And welcome to the session on dependencies. This is a topic that is very important. Over the past 7 years, I've spent considerable time working with large companies, helping them structure for flow at scale. And what I've learned is that dependencies are one of the biggest issues, one of the largest impediments that makes it difficult for organizations to achieve the kind of outcomes they're looking for. And so what I wanted to do today was to address some of the myths that surround dependencies, and at the very end, give you some indication of how to go about solving the problems. But really, we're going to be busting myths today. Inga did a very good job providing an overview of myself. This slide just summarizes some of my background. So I've been doing Agile since the early 1990s, Scrum formally since 2000. At that time, I worked for a startup company that built software for statistical genetics, some sophisticated life sciences software. In 2007, I was the first managing director of the Worldwide Scrum Alliance. I did write a book on Scrum. You can see I've trained a fair number of people and coached with a lot of companies. So what I'll be discussing today is what I've seen at a lot of these larger companies that I've worked with. And so hopefully you can share in those experiences. That's the book. You don't be impressed. I wrote it in English. They were just kind enough to translate it into 9 other languages. So if you speak one of those other languages, by all means, feel free. Unfortunately, it's not in Lithuanian, but maybe one day it will be. So I did write the English version. What we're talking about, the book was published in 2012. So the material I'll be presenting today is newer than it's in the book. So the book makes reference to it, but this is the details. So we're going to look at 9 different myths in our discussion today. And so rather than read these off, I'll just jump right in and we'll address each of the 9. And I want to start, since this is a presentation on dependencies, by defining that word. So here's my working definition of dependencies, right? So there has to be 2 or more entities. There's a relationship between these. These could be resources, they could be activities that require some level of coordination in order to achieve flow. So my team and your team have to work together in order to achieve an outcome. And if we don't coordinate our effort, then work will get blocked and flow is impeded. That's the very broad definition I have for dependencies. Now, I'm interested in those dependencies that involve an entity external to myself. So meaning I'm not interested in our discussion today in a dependency within our own team. So for example, we need to complete task 4 before we can do task 5. That's obviously important, something that has to get addressed, but it's not really my focus. I'm interested in where my team has a dependency on your team. So, and if we don't coordinate, we'll have a big economic problem, economic impact to our work. So to make that a bit more graphical, if we're a single Scrum team and the dependency is within our own Scrum team, that's not really what I want to focus on today. Rather, I want to focus on, for example, my team needs to access that test server. Your team needs to access the same test server, and only one of us can use it at the same time. So we're both dependent on that test server, and we have to coordinate our access. Or my team needs your team to do some work for us, or we will get blocked. Those are the type of dependencies I'm interested in. Okay, so with that in mind, I can now talk about something that I would call shared dependencies, because I share it with another entity. And I can use terminology like requester, the entity that makes the request, and then the servicer, the one that satisfies that request, provides the service. Both of those I would call a dependency entity. And each of those can be really anything. I could be dependent on an organization or another team, Or I might, what if Inga is the only person who can do that work? Well, then I'm dependent on her to do that work. So it could be an individual, could be a client, could be I'm dependent on that product being able to do something, or an application or a resource like a test server. So dependency entities can be really just about anything. Okay. Now, why are dependencies important? Well, for the obvious reason. If the requester makes a request of the servicer and the servicer is unable to satisfy that request in the time frame needed by the requester gets blocked. And when the requester gets blocked, it impedes the flow of the work. So, and that makes things like predictability difficult. How do I guarantee when something will deliver if I can't guarantee that the other teams that have to do the work will actually do the work when I need them to do the work? So this is why they're important to flow. Okay. Now, since we're doing Agile, we have to have Post-it notes, right? It wouldn't be Agile without Post-it notes. So let's say I have a Post-it note, and on there, I have some work item. It could be an epic, a feature, a user story, whatever you want to call it, but it's on this Post-it note. Now, this Post-it note will have one or more dependencies in order to get it done. The collection of all dependencies, I will call the dependency set. And the number of dependencies in this set is n. So we're going to use that variable n to be the number of dependencies. I apologize for doing math, but we're going to have to do a little bit of math there. Okay, so let me illustrate what I mean by that. Let's say we have one Scrum team, and I can give this Post-it note to that single Scrum team. Then n is 1. I'm only dependent on that Scrum team to get this done. Now, let's say I have two Scrum teams. Maybe one of them is front end, and the other is maybe a back end team. So I take my Post-it note, I tear it into two pieces. I give this piece to the front end team. I give that piece to the back end team. Now n is 2, because each of these teams has to do their work, bring it back together, integrate, because this is what the customer wants. Customer has no idea what this is or what that is. This is the feature. So in this example, n is 2. And obviously, if I tore that Post-it note a third time, n is now 3, because maybe I have a front end, a middleware, and a back end team. So think of n as the number of pieces of Post-it note, right? That'll be the simple way. And I'm going to be using n in this discussion, so it's actually an important concept. Okay, so I hope everybody is comfortable with that. Let's start talking about myths. So I'll use mythical creatures to help here. First myth, dependencies, the issue with dependencies scales linearly, meaning if I add more dependencies, the problem gets linearly harder to solve. Yeah, no, it doesn't. Let's see if we can bust this myth. Okay, just a little bit more math, little permutational math. So let's go back to our Post-it note again. I have a single Post-it note. I give it to one team, and I ask them to complete this during the current sprint. I hope you would agree there's only two possible outcomes by the end of the sprint. The team either gets it done or not done. Those are the only two possible outcomes, right? Here's the story. At the end of the sprint, it's either done or it's not done. Now, imagine that I take that Post-it note and I tear it into two pieces. Well, now I have four possible outcomes, only one of which is favorable. There's the outcome where my team gets its piece done, your team gets its piece done. Yay, success, right? We deliver the feature. But notice that there's three other possible outcomes. My team gets it done, your team does not. My team does not, your team does, or unfortunately, neither of us get it done. Tear that Post-it note one more time, so that there's 3 pieces. There is now 8 possible outcomes. Again, only one of those outcomes is favorable. That one, where all 3 teams get done what they said they would get done when they said they would get it done. Notice, however, there are 7 other permutations where at least one team did not complete the work when they said they would. So for those of you who like math, you've already figured out the chances of getting the work done are 1 over 2 to the n, where n is the number of pieces of Post-it note. So as you're starting to see, the problem doesn't grow linearly. It grows exponentially as we add more dependencies. Or to view it a slightly different way, so number of dependencies is in the first column. Now, the squares represent the overall outcome. We said with 1 Post-it note, there's only 2 possible outcomes, done or not done. If there's 2 pieces of Post-it note, there's only 1 favorable outcome. Both teams get it done. There's 3 other outcomes where at least 1 team did not get it done, and so on. So if I tear that Post-it note into 6 pieces, meaning there's 6 teams that have to be involved in getting this done, that means there's 64 permutations, right? 1 over 2 to the 6th power, 1 over 64. Where only 1 of those is favorable. All 6 teams got it done. There are 63 other outcomes where at least 1 team did not get it done. So if in your work environment, you have a large number of dependencies, your chances of getting things done could be very, very low. So another way to think about this is every time we add an additional dependency, we cut in half the chances of being successful. Or if you want to be more positive, every time we can remove a dependency, we double our chances of being successful. So I think we just busted the myth that dependencies as a problem grows linearly. It doesn't. As you just saw, it grows exponentially, right? So your goal isn't to make friends with your dependencies. They're not your friends. Your goal is to try to reduce them when you can, to make n smaller, to reduce n as much as you can, because every time I can reduce n just by 1, I double our chances of being successful. The other approach is to better manage the WIP we put in the system. And if we have time at the end, we'll talk more about that. Okay, so that's myth number 1, scaling linearly. Myth number 2, if we can come up with a solution to managing dependencies, it'll work for all size problems. It'll work for small dependency problems. It'll work for large dependency problems. Yeah. No, it won't. If this is the scale of our problem, we put our team under a magnifying glass and maybe it has to tear up its Post-it note and give pieces out to a few other teams. If that's how big our problem is, we will totally solve this problem. We will. We'll come up with a solution that works. But most of us don't work in organizations where this is the scale of the problem. Typically looks more like this. A lot of teams with a lot of dependencies. There could be a staggering number of dependencies. So if your problem looks like this and you're trying to solve it, let's say you put together a program board. If your program board looks like what I'm showing right now, you'll probably very easily solve this problem. I mean, look at that program board. There's just a few dependencies that are illustrated. It's easy to understand them. It'll probably be rather straightforward to management. So this tool as a solution in the small works just fine. However, if your dependency board looks like that, good luck, right? How will you possibly manage the dependencies that are shown in that picture? Congratulations on drawing the picture, but now use it in some useful fashion to actually manage the dependency problem. So just because a particular solution works in the small doesn't mean it's going to necessarily work in the large. So this idea that one solution will fit the scale of all problems with our dependencies is not likely true. Remember, the problem isn't growing linearly. It's growing exponentially, and we have to be prepared to deal with that difference in scale. So hopefully we just busted myth number 2, that one solution meets all size dependency problems. Let's look at myth number 3. If we could just identify all the dependencies in our work, that mostly will solve the problem because the rest will be just simple management. Yeah. No. Let's take a look at that. Oh, by the way, if you have any questions on any of these topics, please just go ahead and we'll put them in and we'll make sure that we address them. So the first assumption about dependencies, that somehow you can identify them all and that's going to mostly solve the problem, is that you can actually identify them all. Let me make a statement. Let's see if you agree. On the first day of a new development effort or a new project, that's the day we'll have the worst possible knowledge we will ever have about that project, right? Isn't it fair to assume that every subsequent day will be a little bit smarter about what we're doing and not a little bit dumber? If your cameras are on, your head should be doing this right now. Yes, of course, right? We'll learn a little bit more each day. We'll learn into the problem. So the dashed line in this picture is cumulative knowledge. At the end of the project, I expect we would have rather profound knowledge. We just finished it. At the beginning, not so much. The solid line, in this case, would be the number of dependencies that we identify. So if identifying the dependencies mostly solves the problem, people will try to identify all the dependencies up front when we have the worst possible knowledge we will ever have. Look at the gap between what we know, the dashed line, and what we think we know, the solid line. So the first assumption is almost certainly wrong, that we can identify all these dependencies up front. Second assumption, that things won't change. Even if we could identify all those dependencies up front, it fails to take into account that we're going to learn into the problem, that each day we'll learn more and it may change the structure of those dependencies based on what we learn, or that the world around us won't change. I don't know, like COVID might happen, right? And all the work we were thinking of doing now gets altered. So already we have 2 assumptions that likely aren't true, that you can find them all and that they won't change. And even if you could find them all, that's not the killer problem. The killer problem isn't that we don't understand our dependencies. Like, the killer problem is when. Meaning, look, I know that my team is dependent on your team. That's not magic. I know that. What I don't know is when. I don't know when your team is going to do the work. I just know that I have a dependency on your team. Your team might have its own product owner who's making decisions about prioritization, and it may not match my expectations. So the killer problem is the when. So even if we could find all the dependencies up front, we still haven't addressed the biggest problem, when, the asynchronicity. So I think we've just busted myth number 3, that finding all the dependencies is mostly the problem. It's not. Myth number 4. Look, if we just hired better project managers and they used more project management process and they had better tool support, we could solve this problem. We could solve that when problem. Yeah. No. This is not a failure of project management. Let's bust this myth. If this is our situation, we have a single Scrum team And all we're trying to do is manage the dependencies within our own Scrum team. And we even wanted to try to put together a Gantt chart to view it. We could probably easily do this, right? But as I said earlier, that's not the problem I'm interested in, because it's internal to our ability to control the dependencies. I'm interested in a shared dependency between a requester and a servicer. So all I have to do is add a couple more teams in this picture, and it becomes really difficult. Let's say we have 3 teams that have to collaborate in order to get this done. And that plan now represents the work of the 3 teams. I've made this problem really a lot harder to solve at this point, just by that simple addition of a couple teams where we have shared dependencies. And that's really not even the hardest problem. This is where things get interesting. See, there's my servicing team right there. Here's our team down here. And we need that servicing team to do some work for us. So what do? We tear off a piece of Post-it note and we go over and we give it to the servicing team. But notice, we're not the only team asking that same servicing team to do work. In this picture, there are 6 other teams that are asking them to do it. They're each tearing off little pieces of Post-it note and giving it to the servicing team. And that servicing team has a product owner. And that product owner is prioritizing all these competing requests. And ours didn't get put at the top of the backlog. It got put at the bottom of the backlog. So now I can't guarantee when mine's going to get done. So imagine this is happening all over the place within development. A lot of teams are asking the same team to do work on their behalf. This problem just got really complicated. It gets even worse than that. What happens when you have multiple projects that are happening in parallel, each of which has multiple types of dependencies all on the same team? Are we going to put this together again? Again, how in the world will you sort out the when problem if that's your picture? Tell me how you're going to figure out when to do each of those pieces so that you get good flow across the system. You're not. It's not going to happen. So what people end up doing is they create these large, this is our flow chart that illustrates our dependency management process. I made it fuzzy because if you read all the details, it would make you ill, right? So you don't want to see that. And then you have to describe that to people. So what do? These companies put together these PowerPoint presentations to describe their dependency management process, and then they go present it to people. As I said, this is not a failure of project management. What they'll end up doing is then say, well, then we'll support all that with tools, right? We'll come in here and we'll have different tools for mapping out all our dependencies, right? So with more sophisticated process and really good tool support, we'll totally get on top of the dependency problem. No, you won't. You end up building something that looks like that, some weird contraption to try to manage your dependencies. In my experience, and I've been dealing with this problem for a very long time, if you add more and more process with increasing levels of tool support, you don't make the problem better. You only make it worse. You add more bureaucracy to the situation. This is not a failure of project management. This problem falls under the category of don't do this. I said, you're not trying to make friends with your dependencies and come up with a better approach to managing them. You're trying to reduce them, to restructure in a way that they're less impactful to you. Just throwing more project managers and more process at it does nothing to solve this problem. It makes it worse. So hopefully we just busted myth number 4. Myth number 5. Centralized demand management, a form of capacity reservation, that's the solution. So if we have a centralized team and they have the right kind of process and tools, they will solve the dependency management problem for everybody else. Yeah. No. Now, if you're a large company, there is a very high probability you do what I'm about to describe next. And I'm real comfortable it doesn't work for you. So let me take apart the terms: centralized, demand management. Well, centralized means there's a team, a centralized team that's going to manage the dependencies for everybody else. So they oversee a portfolio of work and they coordinate the commitments, right? So there's the requesters who need servicers to do work, and the central team looks at what the requesters need. That's the demand. And they try to secure capacity from the servicers to do it. That's the management part. They're trying to figure out, is there enough capacity of these people to do the work? It looks something like this. This is a really, really simple picture to describe a very complicated process, right? That won't work anyway. So here you have your requesters over here. So these are the teams that need work to come. So they have features, and those features get broken up into these little pieces of Post-it note. So they go to this central team right here, and they go, look, we need teams over there. These are the servicers. We need them to do work on our behalf. And so all of these different requesters go to the centralized team, and the centralized team is trying to secure capacity. Like they go to this team right here. This is team one, and they go, hey, team one, you know, the red team over here needs about 100 hours of work from your team in Q3 in the third quarter of next year. Can you do that for them? And they're trying to balance this all out. What a nightmare, right? And typically companies will do this annually as they try to plan all the work for the next year. No way is this going to work. If you think about it, look at the issues. So if you're the requesting teams, these requesters, think of what you have to do. First thing you have to do is upfront have a complete statement of the work, of the full requirements. Hey, we're back to waterfall again. I mean, you have to know exactly all the work you're going to do to understand what work you need the servicers to do for you. You have to figure all that out at the worst possible time, when you have the worst possible knowledge you'll ever have. Then you have to do all these technical assessments and do an impact analysis. I have to figure out which teams have to do the work for me. Then I have to have all these different meetings, these elaboration sessions to discuss it. And then we have to estimate everything up front. Because someone's got to go to another team and say, oh, red team needs 100 hours of your time. Wow. I can hardly imagine a less agile-like way of trying to approach things. Imagine you're now the demand management team, that centralized team in the middle. I have no idea what kind of project management you're trying to do, but it's heroic because it is at some level I don't understand. You have to start prioritizing things because there's only finite capacity on the servicers. You're trying to optimize for utilization. The model you put together is fragile, meaning the first time something changes, you're going to be redoing the model throughout the entire year. And only a few people have the big picture, that the team, the centralized team. So they better not ever fly on the same airplane at the same time, because if something happens to them, no one has the big picture. So this model doesn't work. So I apologize if your company is doing this. You're suffering a very big problem, and it's not going to solve. This is not your solution. So hopefully we just busted myth number 5. Myth number 6, escalation. Escalation will solve the problem. All right, now, don't get me wrong. There are times when we do have to escalate to prioritize. But if your solution to this problem is, we'll have our CEO or some other high-level executive do the prioritization, you have a model that won't work. Let me show you why. If that's your problem, you'll solve it. Look, here's my product owner, and I have maybe 4 stakeholders all saying, you got to do my stuff. Mine's a higher priority. No, mine's a higher priority. You'll sort this out. You'll figure out how to do it. But in most of our companies, that's not our situation. It looks a bit more like that, right? Where you have a lot of different stakeholders going to a lot of different product owners. And it's worse than this because she is the same person. Remember, she had to tear her feature up into different pieces, and she's giving 3 pieces to different teams, right? So this team gets a little piece of Post-it note, this team gets a little piece, this team gets a little piece. So not only does she have to go yell at each of those product owners to prioritize hers up to the top, she's got to yell at all 3 of the product owners and get them to prioritize it in a coordinated fashion so they all do their work, so that when those 3 pieces of Post-it note are done, they all come back together, integrated, so she has her full feature. Wow, at scale, this is nearly an impossible problem to solve. To show you how bad this is, I just finished a 3-year part-time coaching engagement with the largest bank in the United States. We were moving 7,000 people over to Agile. One of these people, one of these product owners here, this is not a joke, had 86 stakeholders all yelling at them, telling that stakeholder that their work was the highest priority. How in the world do you prioritize the competing requests from 86 different stakeholders and somehow figure that out? It's not going to happen in any reasonable fashion. So this problem gets bad. So what do we do about it? Well, escalation, of course, that's the solution. Is it, though? This is one possible escalation path. Yours could be different. Maybe the single product owner can solve it. If she can't, maybe multiple product owners can do it, working together. Or if they can't do it, maybe a team of portfolio managers, they'll do it. And if they can't do it, it'll move up to the C-suite, people like the CEO or the CIO or whatever C-level person, they'll handle it. And I think most organizations hope this is what their graph will look like, of what percentage of the decisions get made at each level. They're hoping a lot of the decisions get made here at the single product owner level. Some will go to multiple product owners. A few go to portfolio level people, and very few go to the C level. I've never seen that. I think that's what people hope for. To me, the reality looks more like the bottom graph. Yes, some of them do get addressed by the single PO. That's good news. But a whole lot less get addressed by multiple product owners. Why? Because they typically have different goals or different OKRs, right? So you get multiple product owners trying to determine whose is more important. It's like, well, if they work on yours before they work on mine, then my feature may not get done. And that means I won't meet my goal and I won't look good on my performance review. So I find that multiple product owners actually solve fewer of these issues. So a lot more end up at the portfolio level, and more than you think end up at the C level. And if your solution to the problem is, oh, don't worry, our CEO can determine the priorities for us, you have an unsustainable process. Remember, in Agile, the goal is to push decision-making down to the level at which the work is being done. This is a model that's escalating it to the highest level of the organization. Your CEO has other work to do. All right, so this model will not be sustainable. So I hope we just busted this myth that escalation is going to solve this problem. It won't. Myth number 7, feature teams. They're the full solution, right? Everybody knows if we could just create feature teams, all dependencies would disappear. Don't get me wrong, feature teams are a good solution. The myth is that they're the full solution. They are not. Let's be clear on what we're talking about. In the feature team world, ideally, all the teams would be these self-sufficient, autonomous units. Basically, I can take a Post-it note out of my backlog and I can give it to the team, and they're cross-functionally complete. They have all the skills necessary to get the job done. That looks good. Well, in that example, n equals 1. That's good. Now look at a world where you don't have feature teams. Let's say instead we have component teams. And so when we pull an item out of the backlog, we have to split it into its pieces, and we have to put each piece into the backlog of a component team. CA number 1 PB, component area number 1 product backlog. So in this example, N is now 3, right? I had to take the Post-it note and I had to tear it into 3 pieces. Well, what if we could just create feature teams to avoid these component teams? What if we did that? We moved an individual up from each of the component teams to be a member of a cross-functionally complete feature team. Well, now, if I pull an item off of the backlog, I can just give it to that team. I don't have to tear it up into pieces because the team now has all the skills in order to get the job done. So N is now 1. So N went from 3 to 1. So the reason why feature teams are so important is it reduces the number of dependencies by C minus 1, where C is the number of eliminated component teams. So I had 3 component teams. I don't need those component teams anymore for this type of work, so I have that feature team. So I got rid of 3, but remember, there's always still the single dependency that one team has to get it done. So the result is I went from C, basically I eliminated C minus 1 dependencies. That is a huge improvement, right? So in this case, I improved our chances of getting the work done by a factor of 4 because I got rid of 2 dependencies. Huge improvement. Okay, but why aren't they the full solution? Right? We're going to use them. We just have to be thoughtful about when we use feature teams. Well, I'm going to give you just a couple examples of impediments to creating feature teams. So we have a feature team, a component team at the bottom for component 3. We move up a person, right? So we move this person up here. Now, as most of us know, one of the goals when you create these feature teams is to sort of cross-train people to T-shape their skills so people learn additional skills. And the problem you run into in some companies is that the people with the T on their chest, they don't have credentials to go into the code, to access the systems, to make changes. And the component team at the bottom, they don't want to give them access. And the reason is, in some companies, if there's a failure, a production failure, and they can trace the failure back to component 3, then component team 3 is financially responsible for the cost of the outage on that system. So imagine you're that team and you're going to get penalized if the component fails. How likely are you to let other people get into the code and start making changes? People you don't trust. So this one impediment at one of the last companies I did work prevented a number of feature teams from being created. They wouldn't do it. They simply wouldn't allow people to get into the code to get access. It's one impediment. The second impediment is you start depleting a shared services team. And remember, a shared services team is identical to a feature team. So if this is my UX team, and every time a team needs a UX design, they have to go to this team to get it, then they're effectively a component team. Well, what if we want to move people off of the UX team and put them onto feature teams? We start moving them down. That's fine. We move this person down, then we move that person down, we'll move this person down. Well, you can see what's happening. We're depleting the capacity of that shared services team. And so this shared services team still has a backlog. And other teams are asking them to still do work. At some point, this manager up here is going to say, no, you can't take any more of my people. So the first team, this first feature team, will probably have no issues getting a UX person. This team might get it. But eventually you're going to find out you're not going to be able to create more full functioning feature teams because you're going to run out of capacity on the shared services teams. This will put a natural halt to creating feature teams. And then the last one that you often hear people use. This is probably the most frequent reason people say you can't create feature teams. What if a feature cuts across 50 different applications? And in order to have a full functioning feature team, you'd have to move one person off of 50 different teams and put them onto one large feature team. Well, we know in Scrum, teams are roughly between like 3 to 9 people, 5 to 9, that range. They're not 50. So people will argue that I can't create a feature team because it would be too big to put on it all the skills I needed, which might be true. There's actually a way to solve this using what I call coordinated ecosystems. We won't have time to get into all of that today, but it is a real impediment. So feature teams are important, but they're not the full solution. So hopefully we just busted that myth. And that just summarizes what I just said. Myth 8. There's a number of different interaction models between teams, and they can all help with the dependency problem. Yeah, no. One model I would call build for me. This is just classic create more dependencies. I don't know why companies even talk about this. The requester needs the servicer to build something for them, so they put a little piece of Post-it note in their backlog. I don't understand this at all. This is the classic, let's create more dependency situation. So forget this one, bad idea. Another model of working together, build together. I call this not quite open source, kind of, sort of, but not quite. In this example, the requester needs to build something, and they need to build it in this component area over here. But this team provides guidelines, right, on how to build it, and they'll do the review. So they provide guidelines and review. So the requester can actually go into the code and make the changes, but the servicing team still has to review the code. Like they'll do a Git pull request, and the servicing team then has to review it. Look, we haven't eliminated the problem. We've just moved the dependency in time. Rather than asking them to do it for us, we do it and ask them to review it, but we still have a dependency on the review. You might argue it's better because the review should probably take less time than them building it, but I still may not be able to guarantee when they do it. So it's a bit better, but still not great. Build in. I call this one, I get to play in your sandbox. Right. So the idea is really that I as the requester can go into your code and I can build what I need. And you don't get to review it. I just build it and we go to production. Remember, that won't work in this world where you can't even get credentialed access to the system. But this would work. It does break the dependency if I can just go do the work myself, because I don't have to tear up my Post-it note and give a piece to you to go do. This is why a lot of companies today are doing some form of tech modernization to allow this to happen. Now, the one that does work all the time is build using or self-service. And the idea is pretty simple, right? Here's the requesting team on the left. The servicing team builds an API that allows the requesting team to self-service. So, this team over here needs to do some development, and they just use the API. They don't really care what's behind the API. That's just a black box. Who cares? So if the API provides the services needed by the requester, this works. It actually does reduce N by 1. Because I don't have to go to another team to ask them to build it for me. I can build it myself using their API. So self-service is a big win. And if we can architect for self-service, we can reduce dependencies. So that interaction model would work. The myth was that all the different types of interaction models are helpful with dependencies. That's not true. That's myth 8. And then the last one, myth 9, is that we don't need to make any system or architectural changes in order to address dependencies. Yeah, no. stare at it for a moment. If your system architecture looks like that, this is a real picture. I got it from Computer Weekly. This is a mortgage system in all of its dependencies. If your system looks like that, good luck. The lines are dependencies. Then you find that organizations try to create teams to make this work. So they're trying to align their teams with that, and we'll manage our dependencies that way. There's no way in the world this is going to work, right? The idea is maybe you do like an inverse Conway maneuver. Conway's law says that the architecture of the system reflects the communication channels of the teams that built it. Maybe what we would do is restructure our teams to reflect the structure of the architecture that we want to put in place. So the myth here was that you don't need to make any architectural system changes in order to address dependencies. That is, in any organization of size, that is almost certainly wrong and is a myth. Okay, so I don't want to leave you just saying, okay, thanks for showing us where all the problems are. Let's talk a little bit about how we could approach this. I'm just going to touch on this briefly because I want to get into Q&A. There are different classes of dependencies, what I call structural, instantiated dependencies, and blockers. Let me illustrate. If you model your organization, those are the different teams or entities in the organization. And each of those lines represents a dependency. Like in this example, team B has to go to the legal team to get legal review of text that it wants to include in the product. So there is a structural dependency between team B and legal. It's woven into the fabric of the organization, which means anytime team B has legal work, it's got to tear it off and it has to go give this to the legal team. Okay, that's a structural dependency. An instantiated dependency happens when a real piece of work comes up like, hey, team B is working on the new sign-up screen and they need the legal team to review the text of the new sign-up screen. Then there's actually an instantiated dependency. This little piece of Post-it note now exists and it goes to the legal team. So if you're trying to understand the difference and you're a technical person, think of classes and instances. Structural dependencies are the classes, instantiated dependencies are the instances. And a blocker occurs when an instantiated dependency moves into a blocked state, meaning I need the legal team to review this text and I need it by next Monday. If the legal team doesn't complete the review by next Monday, it becomes a blocker because it's now blocking the flow of the work for our team. So the really important point of all of that is if you want the highest return on your investment for managing dependencies, you would go after structural dependencies. Because if I could eliminate that link in my organization, I eliminate all future instantiated dependencies. Meaning, if I moved a lawyer onto team B in the future, team B doesn't have to tear its Post-it notes and get into the legal queue. They can do it themselves. And that actually reduces every future dependency on the legal team. So there are a number of strategies. We talked about a couple of them briefly, like creating feature teams, right? But there's others. There's in fact 7 strategies you can use for improving your structural dependency situation, right? We talked a little bit about this one as well. Architect for build using or self-service, right? And there's others, right? Unfortunately, we don't have the time today to discuss it. And in instantiated dependencies, like identify them, record them, visualize them, coordinate them. And if they become a blocker, then we have to go into blocker management. So a whole set of techniques for that as well. So to summarize, we talked about 9 myths that really are killing your agility at scale. I tried to give you a lens to analyze an organization to see if you're using these myths, these techniques, so you can try to avoid them. We talked about structural dependencies, instantiated dependencies, and blockers, and I tried to give you some examples of how you could make things better. Now, I do a full day class on this, so if you really are interested in the details, feel free. You can get more details at that link right there. But what I'd like to do now, and in that class, by the way, I walk through all those different strategies on how to manage things. So Inga, I'd like to switch to Q&A if we could.
Yes, we have three very good questions. And my suggestion would be for the author of the question to unmute themselves and just ask if you don't mind. So the first one was Audrona. So do you want Audrona to ask yourself?
Yeah, sure. I can, if you hear me well.
Yes.
Hi, Ken. Thank you so much for the good content, many notes to take to our discussions. And my question was the following. So I wanted to ask you from your personal experience, so what methods for minimizing dependencies work best, for you? And then another part of the question was actually, is reorganizing teams to be self-sufficient is a good thing to try out, and either it's the best thing to do, or you could suggest something else?
So it's a great question. These are the 7 strategies that I follow when I go into organizations. So I spend a lot of time at organizations helping them restructure for flow at scale by addressing this problem. The highest, in this picture here, the highest return on investment would be here, which is why everybody talks about creating feature teams, because it really is your highest return. But the myth was that that'll be the total solution, and it won't. The other one that we didn't talk about here, the other for biggest return, is that one. If organizations could balance their system level WIP, how many things they're asking their teams to work on at one time, they would substantially improve their dependency problem. So one reduces the load on the system. The other reduces the amount of structural dependency specifically in the system. And the other 5 strategies all support that. In any company at scale, it's never one of these. It's always a combination, usually all 7. May not be all 7, but it's usually all 7 of these strategies. And by doing that, the first thing you'll do is you're going to make N smaller, which we've already said is a really big issue, right? And the other thing you're going to do over time is this one, which is reducing the WIP in the system. So when you combine those, you'll make the situation better. You will never fully eliminate dependencies. That should not be your goal, because you can't do it. And so don't worry about perfect. I don't know what perfect means. I'm just looking for better. And there'll always be compromises. But most companies can do a substantial improvement by making a few very thoughtful changes. So these are the strategies. Oh, and I should put on here, if anybody wants to get copies of the slides I just did, just send them an email to.
I do.
So hello@inolution.com, where Inolution is that right there. If it's hard to read what I just wrote, but if you send it to there, we'll send you a copy of I'll send you a copy of the annotated version. So great question. What other questions do we have, Inga?
Yeah, we have Rodrigo next. So Rodrigo, do you want to unmute yourself? Just hit.
Sure. Can you hear me?
Yep.
Yes.
Okay, so basically my question is, there's some people that talk about what would be an agile architecture, and the idea there is that you break your product in components and real components that are independently, and then you build the things on that. Wouldn't that solve the dependencies?
So right, what if we could create a set of components, and if we had all those components already built with well-defined APIs, and building new features was the simple act of assembling those components to get the features we wanted without any changes, then our dependency problem has been substantially reduced, because we're in self-service mode, right? We're able to we're not dependent on the other teams. Unfortunately, most companies aren't in that situation. And so they still have to build, excuse me, they still have to build those components, and they still have to interact with those teams to get the components built, and therefore the dependencies exist. But sure, If we could have a complete set of componentry and new features was simply assembling components from assembling features from existing components, then teams are self-sufficient, right? And they don't need to have the reliance on the other component teams. But the question is, are we there in a given company? I haven't seen a company yet that's there, but clearly tech modernization efforts are trying to get them there. That's why most big companies are pushing for microservices at some level. But great question. Follow-ups to that or other questions?
And next one is Anna. So Anna.
Hi, hello, hope you can hear me.
Yes.
So I was wondering if there are any good sources you could recommend, like books, articles, where we could get a bit more knowledge about strategies you were talking about. Yeah, of course, course is an amazing idea, but maybe also some like more available sources.
So great question. There are bits and pieces that are out there, that deal with the different strategies. I mean, obviously there's plenty of literature on component teams, on feature teams, because a very common strategy. So there's a lot written about that. There's also, let me back up to that page. There's also, quite a bit that's out there on system level WIP, right? And there's also, so if you look at each of these topics there, you can find references for all of this one. We didn't really talk much about coordinated ecosystems. That is huge. It is critical. For those of you who are doing like SAFe, for example, most of the scaling frameworks like SAFe or less have a version of an ecosystem in it. Like for example, in SAFe, an art is an ecosystem. It's a team of teams, right? In less, it's a product or an area product. In Nexus, it is the Nexus. Is intended to be the ecosystem. What I'm talking about here goes well beyond what they're doing in terms of a coordinated ecosystem. Excuse me. So there's not a lot that's written about that, but the basics of creating teams of teams that share a common goal, there's plenty written on each of those. So if you go through each of these topics, you can find references. What I'm attempting to do is pulling it all together into a coherent framework. So, but yes, you can find references.
Okay, so I hope that we can also count on your book maybe about this topic at some point.
Yeah, I think I might have permission from my wife to write another book. I've written 2 books and they've been 15 years apart and I'm about at the 10-year point. So usually at that point, she forgets how bad it was. And so she lets me write the next one. So maybe soon.
Lovely, thanks a lot.
Thank you.
Okay, and I think we have last question from Rimvida. Rimvida, you're here with us. Go ahead. I see you unmuted, but we don't hear you. Hello, do you hear us?
You want to read it? Is it in?
Yeah, I think we have some problems. So I can read the question. Do you see in Lietuva?
Which one is it?
Okay, so it's at the top. So if, for example, team A is dependent on team B, who provides platform development for team A? Would merging the team help? If not, what is the answer to this dependency fiesta?
Who doesn't want to have a dependency fiesta? So when you think about, so first question would be is why isn't team A building its own platform? Right. So if they are completely cross-functional and they need platform level assets, just create them. And I understand the comment there is likely about shared platform. It's not just a platform that A would use, but maybe other teams would use as well. So this, who creates the shared platforms is always a key issue in dependencies or core services, things like that. And let me be clear. I'm not saying that you never have component teams. That's dogma, right? Get rid of all of your component teams, create only feature teams. There are times when having the shared component team actually does make sense. And in some companies, they do use that for platforms. And it makes sense in their context. In other contexts, it doesn't. And you'll find that the organizations are using these shared platform teams, but they've created so many structural dependencies. I mean, look at this picture for a second. So let's say that, here's a core services team. You could view that, this is a real example. You could view that as a platform team, but look at the number of arrows coming into that from other important teams. So you have a lot of teams that are dependent on core services. The Android team is, the iOS team is, right? Team A and Team B, they're dependent on it. So imagine how big the backlog for the core services team is going to be when all of those other teams are making requests on core services, right, to do work. So if we modeled this out and took this picture to the next level, where we collected data like how frequently do they make the request? How likely are they to get blocked? What is the cost of delay if they get blocked? We may conclude that that's a bad looking picture and that we might want to do something different. So to know whether that shared core platform team makes sense is you'd have to model it out, right? And then you would know whether, because what if it's really self-sustaining at this point and there's not a lot of requests on that team to make new services? Then it might make perfect sense to have that team. So I hope that addresses that question. I know we're a few minutes past. I'm happy to stay, but I understand there's other sessions and I don't want to impinge on them.
Do we have any more questions? I don't see anything, at least in Hoover. Yeah, but talking even from my point of view, I see myself in one of the slides. I will not mention which one, but it was in one of these like never-ending stripes. But my question to you would probably be, okay, if I have this complicated structure and all these dependencies are like so old and people that work with it till this moment, let's say for 20 or 15 years at least, where to start?
So what I would do first is I would create the model of the organization. Not shown here is there's a spreadsheet or a table that goes with this picture that captures that critical data I was just mentioning. Like how frequently is there a how frequently do we have dependencies over that link? How often do we get blocked over that link? What's the cost if we get blocked? I would use that to prioritize where we would focus our time, right? Because in large organizations, as you said, older, these things have been around for a long time. We don't try to make all the changes at once. That wouldn't be a very Agile-like approach. We're going to do it more incrementally, but we need to figure out where to focus our time first. And so I'm looking for the high impact areas, and we can actually get that data, right, from this kind of model. And then we use that to make changes. And to be clear, you're going to need some level of executive support to do this, because you're talking about making structural changes within the organization. So the individual members of the teams probably cannot make those changes on their own. So it's all about the prioritization and setting up a thoughtful approach to implementing the changes.
Thank you. So I think I'm in the queue for your workshop.
Yeah, I wish I'm actually doing the workshop today. This is day 2 of the workshop, but there'll be more in the future. But yeah, no, again, if anybody wants the copy of the slides, I'll just remember to send me an email. We'll get it to you.
Yes.